Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at software-defined networking. We'll be discussing software-defined networking, control plane and data plane, network virtualization technologies, and then finally, we'll look at traditional and software-defined architectures. This episode is part of my series on enterprise networking, security, and automation for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. A networking device contains two planes or areas of operation. The first one is the control plane. The second one is the data plane. The control plane is the brains of that device. It has the thinking. It makes the forwarding decisions. Do I forward it out this port? Do I look at my MAC address table on a switch and then decide what ports to send this out? On a router, I look at my routing table. Where do I send this out? Layer 2 and Layer 3 routing forward mechanisms is what the control plane does. This is all processed by the CPU, the thinking part of your router. The data plane is also known as the forwarding plane. This contains our switch fabric, meaning how is that switch connected? What are the electronics in the back? And it contains how all of those ports are connected. It forwards that traffic once a decision has been made on that. It uses the information, so the information that came from the control plane, it uses that information to forward the incoming traffic. And to do all of this, there's a special data plane processor to make sure that these functions happen. In software-defined networking, SDN, it's the separation of the control plane and the data plane. We separate those two planes out. The control plane function is removed from each device and is performed by a centralized controller. Your switch, basically, we remove that control plane. You have another device or piece of software here that is now your control plane. The centralized controller then communicates control plane functions to each device. Then this controller then communicates with each data plane and gives it instructions on what to do. Each device can now focus on forwarding that data while the central controller manages the data flow, increases security, and it also provides some other services. To manage a device, you use the management plane and the network connection there to manage your devices. So you have your management plane, you connect that to the network, and that network is connected to those devices you are trying to do that. Network administrators use SSH, TFTP, Secure FTP, HTTPS to access that management plane and configure a device. That management plane is the method in which you, the administrator, can configure your devices in your network. One of the other protocols that we use is Snmp. This is used by the management plane quite a lot, not only to gather information, but we can do our configuration changes using the Simple Network Management Protocol. There are two major network architectures that have been developed to support network virtualization. The first one is software-defined networking, most commonly known as SDN. Now, this is a network architecture that virtualizes the network, offering a new approach to network administration and management that seeks to simplify and streamline that administration process. The second architecture is the Cisco application-centric infrastructure. This is a purpose-built, specifically built for this hardware solution for integrating cloud computing and your data center management. When we talk about network virtualization, there's three components we need to talk about. First one is network programming. Second one is software-defined networking. And the third and final one is network controllers. Network programming looks at how we program and virtualize our network. We look at things like protocols, different programming languages, scripting languages, data model languages, markup languages, and finally architectures and APIs. Protocols like the OpenFlow programming language allows the programming language to control the forwarding planes of routers and switches. Programming languages like C, C++, and Java, scripting languages like Python, Ruby, and Lua, data modeling languages like Yang, and markup languages like XML, and architectures and API like the REST architecture and API used over a web browser, and the Java API with all of its libraries, and pre-written classes, blocks of code. SDN, or software-defined networking, is an approach where the network is software programmable remotely. It involves the Open Network Foundation, which supports the development of SDN and has been responsible for releasing the OpenFlow protocol standard, which is a protocol that separates the control plane and forwarding plane in switches. And we also have OpenStack, and this is a platform here that's used in cloud computing, and it also used to provide infrastructure as a service, which means the ability to manage pools of processing power, virtualized servers, and network storage on an as-needed basis for the customer. I hope you're liking this episode on software-defined networking. If you have the time, please leave a comment and let me know what you think about software-defined networking. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Here you can see a comparison between the traditional architecture and the SDN architecture. Look at our traditional architecture. Each one of these devices, let's say these are all switches here. So switch 1, switch 2, switch 3. They each have their own control plane and data plane. And to configure these devices, you have to go to each one of these control planes and configure that device. In an SDN, or software-defined networking architecture, notice how that control plane has been separated from the data plane. And now those 3 separate devices can be controlled from just a single control plane or a single controller using the OpenFlow protocol. This way, these 3 switches can be programmed from a single point or a single software program. The SDN controller, found right here, is a logical entity that enables network administrators to manage and dictate how that data plane of switches and routers should handle network traffic. The SDN controller orchestrates, mediates, and also facilitates the communication between applications, which is going towards the top of this chart, and network elements, which is going towards the bottom. This is the complete SDN framework, looking at the application layer, the control plane, and the data planes. The proper way to communicate between these is using application programming interfaces, or IPAs. These IPAs, they request services from other applications and other layers here in this ISDN model. The SDN controller uses northbound APIs to communicate with our applications. What this does is it helps the network administrator shape the traffic and deploy services. The SDN controller uses southbound APIs to define the behavior of our data plane. OpenFlow is the most widely implemented southbound API to control those devices in that data plane. Here's an example. The software has been developed using Cisco's 1PK, which is an open network environment platform kit. And that software has been written either in C or Python programming languages. And the application can program the data planes on device 1, device 2, and device 3 using the OpenFlow standard. Network controllers are SDN control plane devices. They're the programmable point of automation. They're used to manage and configure, monitor, and troubleshoot both the virtual and physical infrastructures. And network controllers, they do the automation and configuration of your network infrastructure. The network controller, this is a hardware device. It's a hardware device, which then locates the SDN control plane. An example of a network controller that is used in SDN, software-defined networking, might be the Open Daylight platform. The Open Daylight platform is an open source SDN controller. Here you can see where the SDN controller works with an application to then control our networking devices. The Cisco ACI, application-centric infrastructure, is Cisco's approach to software-defined networking and network controllers. It contains three things. First is the application network policy. Second is the application infrastructure controller, and in this case, the enterprise module. And the third thing is Nexus 9000 series switches. Here we can see how the Cisco APIC EM works. APIC EM enterprise module is the SDN controller. That APIC enterprise module, the SDN controller, that sits between our application and policy and the data planes between our devices. It was my pleasure to provide you with this wonderful episode on software-defined networking. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on enterprise networking, security, and automation for the CCNA. Thank you so much for watching this episode of my series on enterprise networking, security, and automation for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.